Okay, good afternoon, students. We will go through special problems related to domain of the function and other concepts of the function. The domain of the function f(x) equal to log to the base 2 of log to the base 3 of x square minus 3x plus 6. Of course, here is to the base 4 is the domain of the function f(x) equal to log to the base 2 of log to the base 3 of x square minus 3x plus 6 to the base 4 is. So, to get the domain of the logarithmic function, so the logarithm is this logarithm is applicable to positive value of this one. Once you assume this one as x, log x to the base 2 is possible, is defined for x, capital X is positive. Hence, f is defined for log to the base 3 of x square minus 3x plus 6 to the base 4 is greater than 0. Once this part is positive, this logarithm is valid. So, that is, on removing this logarithm, we get log x square minus 3x plus 6 to the base 4 is greater than 3 power 0. 3 power 0 by removing this logarithm. Just once you raise this one to the base 3, we get log of x square minus 3x plus 6 to the base 4 is greater than 3 power 0, that is 1. Again, removing this logarithm, we get x square minus 3x plus 6 is greater than 4 power 1. That gives us x square minus 3x plus 2 is greater than 0, which may be factorized as x minus 1 into x minus 2 greater than 0. So, this inequality valid whenever x does not lies between the roots. X does not lies between the roots, that is 1 comma 2. Hence, domain of the function is or minus the closed interval 1 comma 2, or it may be written as minus infinity to 1, open at 1, union 2 to infinity. This is the domain of the function, given function, logarithmic function. Okay. Similarly, next one, the domain of the function f(x) equal to x power 1 by log x to the base 10 is the domain of the function f(x) equal to x power 1 by log x to the base 10. Here is also the logarithm is applicable to positive reals, and moreover, since the logarithm is in the denominator, it cannot be 0. So that f is defined for f is defined for once x greater than 0 and x not equal to 1, x positive and not equal to 1. Once log x takes the value 1, log 1 to the base 10 is 0. It cannot be 0. Hence 1 by infinity, 1 by 0 is not defined. So that x is positive and not takes the value 1 means domain of f is x is positive. So 0 to infinity except 1. Hence 1 to infinity. The domain of the function f is defined as 0 to 1 union 1 to infinity. Next one. Next problem. The domain of the function of f(x) equal to square root of e power cos inverse of log x square to the base 4, square root of e power cos inverse of log x square to the base 4. Okay. Under root, the root function is defined whenever the function inside the root is positive or 0, that means non-negative. Clearly e power some x, exponential function, exponential is always positive, so clearly this is positive. Hence the function is defined based on cos inverse of log x square to the base 4 itself. Here clearly, here e power cos inverse of log x square to the base 4 is greater than 0 for all x. It is for all x that belongs to, of course, reals, set of reals. So e power cos inverse of log x square to the base 4 is greater than 0, positive. Hence, you need not worry about this square root. Let us observe this one, where this inverse function defined. So, f is defined for this inverse function exists. Once this function exists, inverse function exists, log x square to the base 4 lies between -1 and 1. X square is clearly positive, so logarithm is defined, and x not equal to 0 also, and x not equal to 0. X cannot be 0. X cannot be 0 because log 0 is not defined. Hence, log x square to the base 4 lies between -1 and 1. Moreover, x not equal to 0 to be observed to define the function f. So that is from this 4 power -1, that is 1 by 4 is less than or equal to x square is less than or equal to 4, and x not equal to 0 should be followed to define f. X square lies between 1 by 4 and 4 means, that is, x lies between -2 and -1 by 2, or x lies between 1 by 2 and 2. On squaring this one, 1 by 4 and x square lies between 1 by 4 and 4. Similarly, on squaring this one, it also x square lies also between 1 by 4 and 4. So, x lies either in this interval or in this interval, and clearly x not equal to 0 follows. So that this is valid for, therefore, x from this x belongs to open in closed interval, of course, minus 2 to 1 minus 1 by 2 union closed interval 1 by 2 to 2. In these intervals 0 is not included, of course, that should be observed. 0 is not included because x lies between, this is 0, minus 2 and minus 1 by 2 and 1 by 2 to 2. The x lies in this interval and in this interval 0 is not included, hence f is defined. So, the domain of the function is here, therefore, domain of the function is minus 2 to minus 4 union 1 by 2 to 2 itself. Okay. Next one. Next. Next problem. Domain of fx equal to cos inverse of x by the square root of x square minus step x whole square is the domain of fx equal to cos inverse of x by square root of x square minus step x whole square. To get the domain of the function, cos inverse function, it should lie between minus 1 and 1. Moreover, the square root function is, the function inside the root is positive because it is in the denominator. So, f defined for x by under root x square minus step x whole square lies between minus 1 and 1, and moreover x square minus step x whole square is positive, only positive, it is not equal to 0. Okay. Now we will evaluate this one. That is taking cross multiplication and squaring on both sides. This is x square is less than or equal to x square minus step x whole square. It lies between, of course, 0 and squaring and taking cross multiplication. 0 is less than or equal to square, once squaring this one, we get the value lies between 0 and 1 itself. After that, taking cross multiplication, we get x square lies between 0 and x square minus step x whole square. Okay, and this is x minus step x into x minus step x or x square is greater than, you will take like this. X square is greater than step x whole square. X square is greater than step x whole square. Once x is an integer, these two are equal. Because once x is an integer, step x takes, suppose x equal to k, an integer, this is k square, this is also k square. So in such case they are equal. But the inequality follows in case of x is not an integer. That is clear enough here. X square is more than step x square whenever x is not an integer. Moreover, suppose I will take x as minus 2.4. X square, taking x square, minus 2.4 whole square. Step x in such case is minus 3. The square of this one is 9. Clearly x square is less than step x whole square. So x square is greater than step x whole square is possible whenever x is positive real and not an integer. Not an integer. Whereas once x takes a positive value, a positive real other than integer, x square is certainly 2.4 whole square and step x whole square is 2 square only. Hence in such case x square minus step x whole square is positive. So this is possible whenever x is not an integer and positive real only. Okay. And this is x square is less than or equal to this one. That is x square is less than or equal to x square minus step x whole square implies 0 is less than minus step x whole square. 0 is less than minus step x whole square. Okay. Minus step x whole square is clearly a positive negative integer. Minus step x whole square is a positive integer. This is of course this is a positive integer. Taking minus, this total one is negative. A negative quantity cannot be greater than 0. Cannot be greater than 0. Hence it is not possible. This is not possible for any x. But whereas this is possible for only positive reals except integers. Okay. Except integers. So once of course not 0, positive and not 0 also. Okay. N plus 1, not 0. In case of 0 it may be equal. Of course this which is possible for x equal to 0 only. X is 0 only. So this is which is possible for x equal to 0 only, but x square is greater than step x whole square is not possible for x equal to 0. Therefore, domain of the function is d of f is phi. No such value exists. No such value exists for no such value of x exists for fx is defined. Once it is instead of cos inverse, once it is cot inverse, the domain exists. Once it is cos inverse, the domain does not exist. That is to be observed here. Okay. Next one, ninth one. Ninth one. Okay. Here, ninth one. The domain of the function, the domain of the function, the domain of the function here, f(x) equal to square root of 3 minus 2 power x minus 2 power 1 minus x plus root sine inverse x is the domain of the function, the domain of the function square root of 3 minus 2 power x minus 2 power 1 minus x plus sine inverse x. So this is the function is defined for only 3 minus 2 power x minus 2 power 1 minus x is greater than or equal to 0, and sine inverse x is also greater than or equal to 0, because these two are, the two terms are square root functions. Since the two terms involved in the function, in the definition of the function, are square root functions, hence the functions inside the roots must be positive or non-negative. So f is defined for 3 minus 2 power x minus 2 by 2 power x is greater than or equal to 0, and also sine inverse x greater than or equal to 0. Okay. Moreover, sine inverse x greater than or equal to 0 again, and to define sine inverse function, x must lie between minus 1 and 1 also. To define sine inverse function, x must lie between minus 1 and 1 also. Now let us consider this value. That is 3 minus 2 power x minus 2 by 2 power x greater than or equal to 0 implies. This one is 2 power x whole square minus 3 into 2 power x plus 2 by 2 power x must be less than or equal to 0. On multiplication with the minus, the inequality changes, and then on simplification we get this one. Clearly this is 2 power x minus 1 into 2 power x minus 2 by 2 power x is less than or equal to 0. But the denominator is clearly positive. This one is clearly positive. Hence this must be negative. To follow this inequality, 2 power x minus 1 into 2 power x minus 2 less than or equal to 0 follows. So therefore 2 power x lies between 1 and 2 follows, because the 2 power x, the leading coefficient is positive. That means 2 power x whole square coefficient is positive and expression is negative. Hence 2 power x lies between 1 and 2. So that taking logarithm to the base 2, log 1 to the base 2 is less than or equal to x is less than or equal to log 2 to the base 2. Taking base logarithm to the base 2, log function is an increasing function. There is no change in the inequality. Once the base is more than 1, the logarithmic function is clearly an increasing function. So log 1 to the base 2 is less than or equal to x is less than or equal to log 2 to the base 2. The inequality here not changes because the base is more than 1. Log 1 to the base 2 is 0, is less than or equal to 1. So from this we get x lies between 0 and 1, and x lies between minus 1 and 1, and sin inverse x greater than or equal to 0. Here sin inverse x greater than or equal to 0 implies x lies between 0 and 1 itself. X lies between 0 and 1 itself. Sin inverse x greater than or equal to 0 means yes, x lies between 0 and pi by 2. It lies between 0 and pi by 2. Sin inverse x lies between 0 and pi by 2. In the first quadrant, x takes a value 0 and 1. So from these two, it is clear that domain of f also it lies in this interval. Domain of f is the closed interval 0, 1 itself. Domain of the function is the closed interval 0, 1 itself. Okay. Next one. Next problem. The domain of the function fx equal to 1 by the square root of step x whole square minus step x minus 6 is. The domain of the function fx is 1 by the square root of step x whole square minus step x minus 6 is. Okay. Here is also the square root function is defined only for step x square minus step x minus 6 is greater than 0 because it is in the denominator. You cannot take 0 to that function. So f defined for step x square minus step x minus 6 is positive. So that taking step x as y square minus, of course, raise p, let us take step p square minus 6 greater than 0, where p is step x. That gives us p minus 3 into p plus 2 is greater than 0. Here p square coefficient is 1 positive and expression is also positive. Both are taking same sign. Hence p does not lies between the roots. That is, it does not lies between minus 2 and 3. So p is more than 3 and less than minus 2. Therefore, step x is greater than 3 or step x is less than minus 2. Step x is more than 3 implies that is step x is greater than 3 means it is more than 4 or 4, because step x, once step x lies between 3 and 4 or less, it takes the value 3. So it is more than 3 means x is greater than or equal to 4. Similarly, step x is less than minus 2. Step x is less than minus 2 means x is less than minus 3. Once it lies between minus 3 and minus 2, suppose minus 2.5, it takes minus 3. So x less than or equal less than minus 2 itself. So x less than minus 2 itself. Once it lies between minus 2 and minus 1, it takes the value minus 2. Hence x less than minus 2 only. So x less than minus 2 and more than 4. So therefore x belongs to minus infinity to minus 2, open interval, union 4 to close interval, 4 to infinity, 4 to infinity. Once the step value is less than minus 2, the integer value is less than minus 2 means it is less than minus 2. The integer part of x is more than 3 means x must be more than 4 or 4 itself. Hence the domain of the function is here. Therefore domain of the function is the union of the open interval minus infinity to minus 2, union 3 to infinity. 4 to infinity. This is one important problem based on the absolute, based on the step function, greatest integer function. Next, the domain of the function f(x) equal to sine inverse of 2 minus mod x by 4 plus cos inverse of 2 minus mod x by 4 plus tan inverse of 2 minus mod x by 4. The domain of the function f(x) is sine inverse of 2 minus mod x by 4 plus cos inverse of 2 minus mod x by 4 plus tan inverse of 2 minus mod x by 4 is. Sine inverse function and cos inverse function both are defined whenever the value 2 minus mod x by 4 lies between minus 1 and 1 end itself. Here sine inverse of 2 minus mod x by 4 and cos inverse of 2 minus mod x by 4 are defined for 2 minus mod x by 4 lies between minus 1 and 1. For minus 1 is less than or equal to 2 minus mod x by 4 less than or equal to 1 only. Both the functions defined on the closed interval minus 1 and 1 itself. So that is minus 4 is less than or equal to 2 minus mod x is less than or equal to 4. That gives us minus 6 is less than or equal to minus mod x is less than or equal to 2. That gives us mod x lies between minus 2 and 6. Mod x never be negative. Mod x never be negative. so that mod x lies between 0 and 6. Root 6, x lies between minus root 6 and plus root 6. Okay, x lies between, mod x is less than or equal to, mod x is less than or equal to 6 means that is x lies between minus 6 and 6, of course. And moreover, tan inverse function 2 minus mod x by 4 is defined for x belongs to R. Once this is a real number, for all real values of x, tan inverse function is defined. Hence, tan inverse of 2 minus mod x by 4 defined for all real values of x. Hence, the intersection of these two, it follows and this follows. So, domain of f is intersection of these two means minus 6 and 6 itself. Minus 6 and 6 itself. Okay. Oh. Next one. Next one. The domain of the function. The domain of the function fx equal to, of course, already this was given, fx equal to cos inverse of x plus step x is the domain of the function cos inverse of x plus step x. Cos inverse function is defined whenever x lies, that means this value lies between cos inverse theta, lies between minus 1 and 1. So that f defined for x plus step x lies between minus 1 and 1. Okay. X defined for x plus step x lies between minus 1 and 1. Okay. Step x is clearly an integer. X lies between minus step x minus 1 and minus 1 minus step x. Okay. That is x, we are adding integer part of x which lies between minus 1 and 1. So that let us observe that for what values of x this inequality follows. Suppose x is positive. Suppose x is positive, x greater than 0. Let us take x equal to 1.2. Step x is clearly 1. So x plus step x is clearly 2.2. More than x. It is more than 1. So if x equal to 1 only, step x is 1. So that x plus step x is 2. So it is still greater than 1. So maximum, at maximum, suppose x takes the value once it lies between 0 and 1. X lies between 0 and 1, of course. Step x equal to 0. Hence, x plus step x is clearly less than 1. In particular, x equal to 1 also, it is 2. It cannot be 1. So that x plus step x is less than 1 whenever x lies between 0 and 1. Moreover, whenever x lies between minus 1 and 0, x lies between minus 1 and 0, step x is clearly minus 1. So, x plus step x, x plus step x takes the value. This is minus 1. So, that minus 2 is less than x plus step x is less than minus 1, which is less than minus 1, which is less than minus 1. So, x cannot be negative here, x cannot be negative. Once it is negative, it is still less than minus 1. So, x cannot be negative. In case of x positive, x cannot be more than 1. Once it is more than 1, x plus step x is more than 2 or 2. Hence, it cannot be more than 1 or it cannot be negative. Hence, x lies between 0 and 1 only follows, because 0 and 1 only follows. This is valid only for x lies between 0 and 1 only. 0 and 1. Even it cannot take the value 1. Of course, it may take the value 0 also. So, which is possible? This is possible. This is possible for x lies between 0 and 1 only. Hence, domain of the function is 0, 1, open at 1, open at 1, close it at 0. Let us observe the values of x which satisfies this inequality. Okay. In such case, that is possible only whenever x lies between 0 and 1, and x may take the value 0 also. Hence, the required domain is the semi-closed interval 0, 1.